Alright, so this is trigonometric ratios. First off, we need to know what that is. So a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. Okay, so these are our trig ratios that we're going to worry about right now. We have sine, we have cosine, and we have tangent. Okay, and basically, remember, a ratio is simply one number over another, or a fraction, right? So sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and I'll talk about adjacent here in a second, as well as tangent. Tangent is the opposite over adjacent. Okay, so I know it sounds kind of weird, but here's what we have as a right triangle, and we have our angles, A, B, and C. Those are uppercase, and then we have our sides, which would be our lengths, lowercase a, lowercase b, and lowercase c. So when I say the sine of A, I'm talking about this angle right here, okay? And our trigonometric ratios are all based on where you're at. So when I say the sine of A, I'm talking about this angle right here, and I'm talking about the opposite over the hypotenuse, and I'm talking about side lengths here. So if I'm going to compare, if I'm going to find the sine of A, I need to find the side that's opposite this angle, and opposite to A is the lowercase a. And the hypotenuse, well, the hypotenuse is always the longest side or the slant side, right? So that would be my C. So if I were to find the value, it would be whatever A is equal to over C, okay? Cosine of A. Well, now the cosine is adjacent over hypotenuse. And when I say adjacent, I mean right next to, okay? And we're talking about A here. So if this is A, the cosine, the side that's next to A is B. And I know that C is also next to, but C is the hypotenuse, right? So whenever I say next to, it's the side that's next to that's not the hypotenuse, okay? So next to and, or adjacent over hypotenuse. So adjacent to A is B, and hypotenuse is, oops, C. Almost wrote A there. So the cosine of A is B over C. And then the tangent of A, well, that's opposite over adjacent. Opposite, again, is A, and adjacent is B. Okay? So again, remember how I said it all deals with where you're at. So you could also find the sine, the cosine, and the tangent of B. And if you want to, you can go ahead and do that right now. But remember that B is over here. So the sine of B and the sine of A, even though we're dealing with the same triangle, we're not going to get the same values. So the sine of B, again, we'd be standing or being right here. The sine is opposite over hypotenuse. So the opposite is B, the hypotenuse is C. So I'm going to say B over C. And again, you can see that the sine of A and the sine of B are not the same. Okay, but what you should also notice is that the sine of B is actually equal to the cosine of A. Okay, a little interesting thing there. So cosine of B, let's take a look at the cosine of B. Well, cosine, again, we said is adjacent over hypotenuse. And adjacent to B is A and C, but C is the hypotenuse, so adjacent must mean A, and the hypotenuse is C. So notice that the cosine of B is not equal to the cosine of A, it's equal to the sine of A. And then we have the tangent of B. Tangent is opposite over adjacent. So again, I'm here at B. Opposite is lowercase b. Adjacent is A. Okay, so again, it all deals with where you're at. Notice that I don't have the sine, cosine, or tangent of C because C is the right angle, and you'll never use your trigonometric ratios with the right angle. Okay, so you're always going to be dealing with these two angles here, A and B, never the right angle, okay? Because these angles can change, but this one can't, okay? And you'll get a bunch of nonsense if you try and use a 90-degree angle. So this right here I haven't talked about yet, but this is a little acronym to help you remember these trig functions, because they can be kind of hard to remember. So to help you remember, we have this little acronym, and it's, the way I say it is SOHCAHTOA. Okay, so SOHCAHTOA, and basically it's just a real quick acronym. S stands for sine, O stands for opposite, oops, H stands for hypotenuse. So is sine equals opposite over hypotenuse. K is cosine equals adjacent over hypotenuse. Oops. T is TOA, that stands for tangent, and tangent is opposite over adjacent. Okay, so now this is kind of a lot to remember, but we are going to spend a couple days on this, but the main thing to remember is SOHCAHTOA. Okay, sine is opposite over hypotenuse. C-A-H, that's cosine is equal to adjacent over hypotenuse. TOA, that's tangent is equal to opposite over adjacent. Okay, this is why this little acronym is helpful. It can help you go through them real quick and memorize them. Okay, so let's look at some other types of problems that we could possibly come into. The first one is, it just says find the sine, cosine, and tangent of B. So again, here I am at B, but instead of those letters, now we have actual numbers. So all I'm basically asking you to do is plug in your numbers and see what you get. So the the sine of B. B is right here. Sine is, well, remember SOHCAHTOA, so is opposite over hypotenuse, and the opposite from B is the opposite side, which is 3, and the hypotenuse is 5, okay? And of course, you're always going to be wanting to find the decimal equivalents of these. So 3/5, well, each fifth is worth 0.2%, so that would be 0.6%, or 0.6, excuse me, not percent. Cosine of B, and again, here I am at B. Cosine is K, that's adjacent over hypotenuse, so I have 4 over 5, and that's going to be equal to 0.2 more than 0.6, so 0.8. And the tangent of B, and again, tangent is opposite over adjacent, so I end up with 3 over 4. And 3 over 4, well, that would be 0.75. Okay, so these are real quick calculations. It's all about knowing your sine, cosine, and tangent. So best thing to do is just try and memorize those as quickly as you can. Okay, these last two problems, basically I'm asking you to find a side length. So now we're going to be doing something a little bit different. And here's where your calculator is going to come in handy. So let me grab mine real quick. We have the hypotenuse equals 18, this side length equals x, and that angle equals 17 degrees. And I'm going to show you how to do that real quick. So you need your trusty calculator. I have mine right here. And again, you're going to need a calculator with sine, cosine, and tangent. Okay, so let's get on this. So basically what I'm going to do is I'm going to know, well, I have these functions here, these trig ratios, and I need to figure out which one uses the values that I have, because I don't have this opposite side of this angle. All I have is, I have my adjacent, and I have my hypotenuse. So I have to think to myself, which trig ratio uses adjacent and hypotenuse? Well, that's cosine, right? Cosine is K, adjacent over hypotenuse. And it's always of the angle, right? So the cosine of this angle, which is 17 degrees, is equal to, and it's always a ratio, right? So it's adjacent over hypotenuse, so it's x over 18. So here's where the calculator comes in handy. All I have to do is plug in my angle measurement and hit cosine, and it will tell me the value of the cosine at 17 degrees. And now I get a decimal of 0.95, and I'm just going to round it to 3 decimal places. It's 9563, so I'm going to say 956. Okay? And you're always going to get decimals. This is where you just have to trust your math here. Okay? So what I'm trying to do is I'm trying to get x by itself to figure out what the side length is. And again, you're going to get decimals even in your answers are hardly ever going to come out as whole, round, nice numbers. So what do I have to do to get x by itself? Well, right now x is being divided by 18. So all I have to do is multiply both sides by 18, right? Because if I do that, it cancels out here. But if I do it to one side, I must do it to the other. So I'm going to take that answer and multiply it by 18. And I get 17.213. Okay? And you're going to want to try this in your calculator. Make sure you get the same numbers as me. Again, I'm just rounding to 3 decimal places. Okay? So that would be your answer right there. That's how I find x. So let's do it again, except now our unknown is here. Again, we still only know 2 sides and we only know 1 angle. But if you're really good at this, you could actually realize that you can actually figure out what this angle is too and use a different trig ratio if you wanted to. So let's take a look at this. It says I have 32 degrees and I have my, well, compared to this side, I have the opposite side and I have my hypotenuse. So again, I have to think about my trig ratios. Which one uses opposite and hypotenuse? Well, that's sine, right? Sine uses opposite over hypotenuse. So I'm going to say sine of 32 degrees is equal to 12 over x. Okay, so now x is in the denominator. It's going to be not so fun. This is where if you could figure out this angle, it'd be a little bit easier. You can always make sure to try and get your variable up in the numerator instead of the denominator. But let's go ahead and do this just how it is. Okay, so the sine of 32 degrees, again, I'm going to go to my calculator and I'm going to say the sine of 32 is equal to, I get 0.5299. So I'm going to say 0.530. And that is equal to 12 over x. Okay, again, all I'm trying to do is get x by itself, so I'm going to have to do a little bit of manipulation here. To get x out of the denominator, I have to multiply by x, which means I have to multiply this by x, and I get 0.530x is equal to, those x's cancel out, I'm just left with 12. Now I have to divide the 0.530 from both sides, and we'll get our final answer. X is equal to, let's see, it's 12 divided by 0.530. I get 22.642. And the reason I say 642 is because I got 6415. And so because the 5 is my 4th number, I'm going to round up my 3rd number to a 2. Okay, so x equals 22.642. Okay, so again, there is a different way to do it. You could easily find this one, and then you would see that you have your adjacent and your hypotenuse, in which case you could, again, use cosine, and your unknown would be in the numerator, but you should still get this value right here. Okay, so like I said, I know this is quite a bit in one lesson, but we're going to be spending a couple days on this. We'll start out slow, slowly work our way up to problems like these, but make sure we get it down before we move on. Okay, remember to write down your questions if you have any, and be prepared for class.